As you may know, light is a transverse wave. That means it can oscillate up and down, right and left, or in diagonal in any direction that's perpendicular to its direction of propagation. You might already know what a polarizer is. A polarizer looks like this. It's a device that has lines that go in one direction, parallel lines, that you can't really see with the naked eye. But what it does is that it prevents all directions that are not parallel to those lines from passing through. So let's see what happens to the light when we put polarizers in front of it. So right now we're looking at just a normal light, regular light, that has all directions of oscillation. The particles that are coming out of it are oscillating up and down, right and left, and in diagonal, all of the possibilities. Let's see what happens when I put one polarizer in front of it. So with one polarizer in front of it, you might have noticed that the light just dimmed a little. That's because from all of the directions of oscillation, only the ones that are parallel to the direction of the polarizer are passing through. I can change the angle of the polarizer from 0 to 90, 180, 270, back to 0, and nothing happens. The dimming is the same regardless of the angle. However, what happens if I put a second polarizer in front of it? So I put a second polarizer at the exact same angle, it's 0. And now I want to see what happens when I switch the angle. So this is 0, I'm going to move it to 90 degrees, and you'll see that the light basically gets down to 0. That's because the light that passed the first polarizer was the one oscillating up and down. But to pass the second polarizer, the light would have to oscillate right and left. So no light can pass through both. They're either oscillating up and down or right and left, not both. So if I keep moving the angle, when the angle is parallel to the original polarizer's angle, all the light passes through, and when it's perpendicular, like at 90 or 270, almost no light passes through. So the effect of one polarizer is just dimming. The effect of two polarizers depends on the angle and can be no light passing through at all. This next experiment is going to show us how white light is created and how different colors can be added to create all of the other colors. This machine can give us 3 colors, red, green, or blue. If I turn them all on, right now it's going to give me 3 separate circles, red, green, and blue. Maybe you've heard RGB, that are the colors that lights use. So if you go to the theater, they're going to have 3 colors of spotlights that they're going to combine in the way they need in order to create any color. What happens if we move them closer together? We can see that now there's some intersections that get bigger and bigger as I turn this around. So let's see what happens with each combination of colors. If I have only red light, I'm going to be able to see a red circle. But if I add to that red light green light, in the middle of both, I'm going to see yellow light. If I add red with blue, I'm going to see magenta. And if I add blue with green, I'm going to see cyan. This gives me the 3 colors that printers use: cyan, magenta, and yellow, CMYK. That's because the opposite of light is true in ink. You need the 3 opposite colors in order to get the combination. You can see now that in the center there is a white spot. That means that by adding red, green, and blue, you can exactly get white light. That's why you only need those 3 lights in order to create any colors. In this third experiment, we're going to use a device called a diffraction grating. You might be able to see here that each one of these holes has a different number of lines that are very, very thin. And the light is going to try to pass through there and create patterns of interference. So right now what we're looking at is the laser just passing through the first, which is a normal hole. It can pass completely and it creates no interference. But if I switch into a diffraction grating, you might be able to see there that there's a pattern of interference. There's not just one line, there are multiple lines on either side. This will become clearer as I put more diffraction gratings with more lines. For example, here you can see a clear one in the middle and others on the sides. I can switch this up, the number of gratings, the distance between the gratings, and this will just change the pattern into many different patterns, but all of them have a bright center light mixed with some dimmer lights on each side. This is actually how they discovered that light is not only a particle, but it has wave behaviors as well, because particles do not do diffraction, only waves. That means that light has to be a wave for it to create a pattern of interference. It diffracts and then it interferes with itself.